Hey there. So, in this lesson, we'll be talking about trigonomic ratios with acute angles. So, in a sense, more accurate, we'll be talking about triangles that have a 90-degree on it. So, right triangles. So, this is a right triangle right here, and the angle could be either at the A or C, but in this case, it's the A. And based on where the angle is, that it will determine what your opposite and adjacent is. The hypotenuse, as you can see here, will always be the longest line, or will always be the angle. However, the opposite is always opposite relative to the angle. So if the angle is here, right across from it, this is the opposite side. Adjacent is right beside the angle, right over here, right beside it. That is the definition of adjacent. Adjacent actually means beside. You can say, my friend is sitting adjacent to me, which means beside. Opposed to saying, my friend sits opposite from me, he's sitting on the opposite side of the table. So here, this is the angle, and opposite is right across. So that's how you can label your triangles to know the opposite, the hypotenuse, and the adjacent. Now we have this very famous formula called SOHCAHTOA. And if you say really fast, it sounds like a chant, like SOHCAHTOA. So that's an easy way to remember, just to chant the word itself, SOHCAHTOA. And then it basically refers to this formula here, sine angle over opposite or over opposite to hypotenuse. Here, this one here is cos is adjacent over hypotenuse, and tan is opposite over adjacent. So SOHCAHTOA is just an abbreviation for this formula or these set of formulas. Okay, so the best way to learn these problems or to learn the concept of this, and by the way, this is a very useful formula and concept because a lot of times we are working with right angles in everyday life. So it would be nice to be able to measure it. And just so you know, you can also use Pythagoras theorem to solve any unknown sides, given that you have two sides for at least. So Pythagoras theorem can also be used with some of these problems. But in this specific lesson, they want you to use SOHCAHTOA. So that's what we're going to try to do. Okay, so determine the sine and cos and tangent angle for all of this. Well, the first thing we have to do is to identify on this triangle what your opposite is, adjacent is, and hypotenuse. The hypotenuse will always be the longest line from A to B or B to A. That will always be the hypotenuse. However, the opposite is always opposite from the angle. So this will be opposite, and the only thing left is adjacent. It's always beside the angle. So we know that this 26 is the hypotenuse, 10 is the opposite, and 24 is the adjacent. So now they want you to write down the trigonomic ratios. So we're going to do here is sine the angle, which is if you remember SOHCAHTOA is SOHCAHTOA. So for sine, it'll be opposite. Well, I'm just going to write down opposite over hypotenuse, which is essentially the same thing as saying 10 units over 26. And you can put that in the calculator and you can figure out what that ratio is, which is basically 0.38 units. In short, I'm going to give myself a little bit of space. I'm going to do cos, the angle. Cos is adjacent over hypotenuse, which is the same thing as saying 24 units over 26 units. And if you drop that in the calculator, we should get 0.92 units. And lastly, tan, the angle, and essentially it is opposite over adjacent, which in this case is 10 units over 24 units. And if you drop that in the calculator, you get 0.42 units. Okay, good. Easy enough. Next question. Determine sine, cos, and tangent for Q, the angle of Q, which I drawn here, and in for 3 decimal places. Okay, so let's take a look at what we have. Oh, just so you guys know, all triangles, the angle should always equal will always equal 180. If you add up all the angles, you add this angle plus this angle plus this angle, it will equal 180. But you'll see that being useful elsewhere, maybe a little bit later on for some of these problems. But in the meantime, we are going to determine sine, cos, and tangent of this angle here. So the first thing we want to do is find what r is. And I know this is a right triangle, so I can use Pythagoras theorem. And I'm just going to use it right over here. And I know the formula. The formula is basically the hypotenuse, which is that, squared with p squared plus q squared. Therefore, r is root. P here is 4.2 squared plus 3.3 squared. Let me just, oops. This doesn't look like a 3. There we go. Okay, it's a little off, but the value there should be 5.34, 5.34, 5.34. Okay, that's that value there. So we know what r is. Now that we know what r is, then we can figure out sine, cos, and tan for q. So we're gonna do first one. We're gonna do sine, and then the angle. Sine is if you remember SOHCAHTOA, SOHCAHTOA. It is opposite. In this case, the opposite is that, and that's the adjacent. So this is adjacent, this is opposite, and h is the hypotenuse. So this one here, sine is opposite, and I'm just going to write it in. Opposite would be 3.3 over hypotenuse, and we calculated what the length is of hypotenuse is 5.34. 34. And we get a unit of 0.623. 623. In this case, it's expressed in meters. Now we have cos, the angle. Same thing. It will be the adjacent over hypotenuse. So it'll be 4.2. Hypotenuse is 5.34. And we should get 0.792 meters. And lastly, tan or tangent will be opposite over adjacent. Opposite is 3.3 over 4.2. And then we'll get 0.786 meters. Okay, so that example is done. Another definition, because sometimes you may come across these problems, the angle of depression and the angle of elevation. And it's always relative to the horizontal. So first thing you do is you draw a line that's going sideways, a horizontal line. And if it's the angle of depression, another angle is always pointing downwards. And this here is the angle of depression, and same thing with the angle of elevation. You draw a horizontal line and basically draw a line upwards, and this is the angle of elevation. That's just some definitions. You might come across some problems that involve that, but well, we'll figure them out as we move on. So it says here, determine the depth of, okay, Pablo has a well behind his cottage. To measure its depth, he measures the diameter of the well and the angle of depression. So over here, you can see right there, uh, this here is basically over here. It's this basically these two. Let me just get my pencil too. It's basically the same thing, except they just redrawn, so it's easier for you to see. Here, this is the exact same thing, and this is the angle right here. If you had identify the opposite and adjacent, this here would be adjacent. This would be the opposite, and this would be the hypotenuse. And if you remember SOHCAHTOA, so ka hoa. So to find D, we can use SOHCAHTOA. I can tell you, but looking at this information, we have an angle, which is good. We can use SOHCAHTOA for that. And then we have adjacent, and we need the opposite. So O and A. Then therefore, I think I'll use the tan. Tan will fit nicely. So tan 72 there. It's at 72 degrees, and it is O over A, which essentially is D, in this case D over 6. Rearrange the equation, so you should have D equals 6 tan 72, which in a sense that gives you 18 feet, approximately 18 feet. Good, easy enough. Next problem. We have another triangle. It says here, Sonia is building a skateboard ramp. She wants to have a vertical rise of 0.5 meters. 0.5 here is expressed in centimeters, but really it's let me just write that in so it's easier to see, because we want to work in the same units. And so I'm going to put down over here 0.50 meters. So I just did the conversion right here. 0.5 meters. So 0.5 over the horizontal distance of 1 meter, which we have here. At what angle elevation should she build the ramp to the nearest degree? So basically, you're looking for this, the angle elevation. So again, we know that this will be opposite, this will be hypotenuse, and this will be adjacent. The two pieces of information that we have is the adjacent and opposite, which means that we'll be using tan. Again, it's always good to write down SOHCAHTOA just to confirm for yourself that you're using the right formula. So, SOHCAHTOA, and we have that and we have that, so we'll be using tan. So, tan, the angle, equals opposite, which is 0.5, over adjacent, which is 1.0. And to find the angle, we get the inverse of tan, which is tan -1 bracket 0.5 over 1.0. Pop that in our calculator, and we get 27 degrees. Okay, good. Next problem. Or the last problem. We're there. We're almost finished the lesson. Okay, let's read this. So, we have a triangle. Its TUV is a right triangle. Like you see, this symbol here represents a right triangle, such that U is 90 degrees, and then U. Just so you know, when we do these letters, often the small case represents a side, and the uppercase represents angles. So over here is small u, which is 5.4, and V, this is capital V for the angle, and the small v for the side. And I'm just gonna put it here so you can see it. So this would be small u. I'm gonna do that for small u, and this would be small v. I'm gonna do that for small v. And solve for TVU for an angle to the nearest. So basically, you want to solve TUV for angles to the nearest degree and the sides to the nearest 10th meter. Okay, so I'm gonna do two equations here, but there's a shortcut method to this. So I am going to solve for the angle t and then the angle. Well, actually, let's use another method here. Okay, let's try this. Let's just say this will be theta 1 and this will be theta 2, or just t, or just the angle t, and then this will be angle v. Maybe that's better. Okay, so I'm gonna say because this is angle here, this will be angle here. So we have opposite and adjacent for referring to this one, referring to the angle t. This will be the adjacent and this will be the hypotenuse. So let's write down so ka toa. So referring to this angle, we have adjacent and we have opposite. So that will refer to this one ka. So I'm gonna say here cos and capital T representing the angle, and it's adjacent over hypotenuse, so it's 3.2 over hypotenuse, which is 5.4. And to get T, it's the angle T goes like this. That represents the angle. It's the inverse of cos. Let me just erase that. The inverse of cos brackets 3.2 over 5.4. Drop that in a calculator and we should get 36 degrees. 36 degrees. Okay, so we found that. Now let's look at angle V over here, the second angle. So if the angle's here, that will be opposite, and that will be the hypotenuse. So opposite and hypotenuse, we're gonna be using this formula here because it has opposite and hypotenuse. So sine, and the angle is V, and it will be opposite, which is 3.2 over 5.4. And to find the angle, we get the inverse of sine, bracket 3.2 and 5.4, and that gives us a value of 54. Okay, good. Now I want to mention that the sum of all triangles will always equal 180. So if I wrote down 180 here, and I added all three angles, so there's three angles here, one angle is 90 degrees, plus 36, plus 54, and so they all should add up. So if you only have one angle, you can figure out the rest. For example, if you're looking for, let's say, the angle of t, and you have let's say you're looking for the angle t, so basically it's 180 minus 90 minus the other angle, which would be was t here was 36, so you get the other angle would be 54. And you will find that that angle will equal 36. Similarly, if you're trying to find the angle of V, it'll be 180 minus 90, that's the angle right here, minus the angle that's remaining, which was, in this case, 36. And that will give you an angle of 54. So this method could save you a lot of time in terms of calculation. Like here, we did the calculation both separately, but in reality, we could have just done this calculation alone and then drop this number here into here and figure out what the other angles by just using 180 minus 90 minus the remaining angle, which is 36, which gives you 54. So this could be a shortcut method that you can use. So you have a lot of, so you don't have to use it, but I'm just saying it could be a shortcut method because all triangles, all the angles of a triangle will always equal 180. Okay, so that's it for the lesson. And yeah, good luck with the homework.